Hello, Nagendra? Can you unmute and talk, sir? Nagendra? There is unmute button in the meeting itself. It's look like orange color. Hello? Hello? Nagendra, can you unmute and talk, please? Hello?
హలో
అది అన్మ్యూట్ చేసి మాట్లాడండి సార్.
వినపడుతుంది నాకు.
కానీ మీరు మీ మాట మాకు రావాలి కదా, మీరు మ్యూట్ లో ఉన్నారు, అన్మ్యూట్ చేయాలి అక్కడ. మీటింగ్ లో మైక్ అని ఉంటుంది చూడండి, అక్కడ మైక్ సింబల్. ఇప్పుడు మాట్లాడండి. వినపడుతుందా మాది? హలో
హలో
నాగేంద్ర వినపడుతుందండి? ఓకే, శివ్ ఈస్ దేర్. శివ్, కెన్ యూ టాక్ టు నాగేంద్ర ప్లీజ్?
Hello Nagendra, good morning. How are you?
Yeah, hi Shiva. How are you?
I think it's very early for you.
Yeah.
Okay, no problem. So, have you gone through the demo video that Shiva shared with you?
Yeah, I've seen it.
Do you have any question?
No, I want to know this concept only.
Okay.
This is fine.
And so, you work with Java or some other technology? Are you working currently with Java?
Actually, Java and Fusion middleware.
Okay. Your voice is very low. Can you please increase a little bit of volume? It is very low.
Yeah, I work Java and Fusion middleware.
Okay.
On those things.
Okay.
Like OSD, Beetle, and Java JT technologies also.
Okay. Do you have any experience on any enterprise service bus or integration framework like we work in ESB?
OSB I worked with.
OSGI.
OSB, Oracle Service Bus.
Okay, Oracle Service Bus. Okay, okay. Okay. Fine. And have you done the setup required for the
Yeah, I've done it.
Okay. So you know, like, so you installed Fuse as a Windows service?
Yes, Windows and Fuse and JBoss developer.
Okay, fine. Then we can start with some basic things, right?
Yeah, no problem.
Okay. Yeah, so today I'll give you some basic detail, and then we'll start with it. So,
Yeah.
Basically, JBoss Fuse is an enterprise service bus, and it is based on Apache Kera-based runtime container. And so, see, it's like an application server, right? Fuse is like an application server you can take. And for running any application server, you need to have a runtime container, right? So, in case of Fuse, the runtime container is Apache Kera. and
Yeah.
Apache Keras is a OSGI based runtime. So in Java, normally if you look any application servers like standard JBoss or Tomcat, they are called the J2E container. So Fuse is using another container. It is called OSGI container. So OSGI is like a modular concept in Java where we write some extra logic to define our dependency and services that we are there for other applications. So normally, if you deploy any application in Tomcat, what we do, we will have a war file. Inside that war file, I will have many jars. Some of jar will be my application jar. Some of the jar will be in dependencies, third-party libraries, and other modules. So all of them will be putting together in a war file and deploy in the Tomcat. Then my application will be running. In case of JBoss Fuse, we'll write our application and we'll build it using Apache Maven, and then we'll deploy in Fuse. But the difference here is I will not be bundling, I will not be putting together all the dependency jar, extra dependency jar. If my application needs, let's say, Oracle database jar or MS SQL Server database jar, or any third-party libraries like Common Lang jar or Common IO jar, I will not be combining them along with my application. And then I will just deploy my application. Then the question is how the container will resolve the dependencies of my application. So maybe I want to use an Oracle jar or SQL Server jar or third-party jar, but I am not providing those jars along with my application. So how Fuse will resolve the dependency of this application? So in my application, while I am developing the application, I will tell that these are I will provide a list of dependencies, and based on the list of dependencies, Fuse will resolve those dependencies. So that is the OSGI way of doing the dependency resolution. You don't provide extra jar with your application, but you just tell what are the jars required for your application. So based on that information, container or the Fuse server will take care of your deployment. Okay, that is the difference between traditional approach and the OSGI approach. So in traditional approach, you will create a project, and that project will have some packages, and it will have some property files or configuration files, and then you will build the application using the Maven, and you will get some jar file, or you may combine multiple applications and build a war file. Here in Fuse, we will not build a war file, we'll build a jar file, but that jar is a special jar, it is called bundle. Okay? So this bundle is similar to a jar file. If you see one bundle and one normal Java jar file, both will look same, they will both have extension of jar, and both will contain your packages and configurations. But in the case of bundle, there will be extra file. It is present inside meta.inf folder. It is called manifest.mf file. In normal Java also you will find manifest.mf file, but it will not have many entries. And but in case of OSGI bundle, you will find that the manifest.mf file has more entries compared to a normal jar. Actually, this manifest file is used by OSGI or Karaf or JBoss Fuse. All of them are equivalent in case of Fuse now. It will be this manifest file will be used by this server to find out what are your dependencies and to resolve those dependencies. Okay. So if you have installed Fuse, then you will see that. Let me open that location. If you have installed Fuse, you will have a folder location like this. Here you will find that there is a folder called system. Inside the system, you will find there are a lot of folders, and inside each folder you will find a lot of jars. So these jars are provided for resolving the dependencies of your application. So Fuse contains like 500 MB of this kind of jar. This is an offline repository. So from this repository, all the jars will be loaded as per the application requirement. So if you want 10 jars, it will be loaded from system folder. If you want 100 jars, it will be loaded from system folder. Okay. Here you don't have to give any jar to Fuse. Sometimes what could happen, you can run a build application that may need a jar which is not available with fuse. So if it is not available with fuse, then it will not be able to provide from the system folder. So what will happen in that case is, fuse also have a list of repository from where it can go and download the jar. So if you go to the etc folder, there is a file called or.ops4j tax url.mbn.cfg. So here there is a list of repository which can be used by Fuse to download the dependency if it is not present in Fuse. Okay. I'll be sharing this list with you so that list of useful files with you so that you can later go back and check out. So these are the Maven repositories from where normally any application developer will be downloading the dependencies. So suppose that you are running Fuse in an environment where internet is not available, only sources are available, resources are available on intranet. Then normally in any organization they also have this local repository for development purpose and deployment purpose. So we can use this local Nexus Maven repository, and if you have any such repository, you can give the path of repository here. Then Fuse will download it from there instead of going to internet. Okay. Fine. So this is the dependency resolution part. Normally in JBoss Fuse, if you run the service of Fuse, it will be running, and then you can create the application in Developer Studio, write your camel routes, and then build it and deploy in the Fuse. So in Fuse, you can deploy multiple ways. Normally for testing purpose, you can do hot deployment. So if you go to this JBoss Fuse home where you have extracted the package, so you will find there is a deploy folder. So in that, yes.
One request, I want to know the 6.3 and JDAO thing.
What do you want to know?
6.3.
6.3 of Fuse version.
Yes, yes.
Okay.
And the JDAO 10 version.
Yeah.
It will be different, right? Both. That's why.
I have not downloaded 6.3, but I am using Fuse from 6.0 version onwards, and right now we are using 6.2.1. But I have not find any difference in deployment or the way you write application.
Okay.
I have not seen any difference.
View part and a little bit different. That's why.
The core will remain the same. New part will be some support for new components. It is not that old component will be removed.
Okay. Okay.
So there are a lot of, we'll go to that point, there are a lot of features and components and patterns available with Fuse. And we may not be using all of them also, like there are 200 plus components. But in normal day-to-day integration project, you will be using maximum 20 components. You will not be using another 180 components. Some of components are with social media interaction. If you have any project, then only you will be using them. In the Developer Studio also, I'm using this 9.0, and I have 9.1 also, but there was some problem with that. Core feature-wise, there is not much difference. And these are more like tools, so they can change version anytime. But what should be the focus then? How to do the integration in Camel, right? Not how to learn more on the tool side. Because these are tools, you know how to use them. So it's a drag and drop is available. You can build it, you can run it. All those features, common features remain the same. There's no difference in that. Okay.
Yeah.
So deployment wise, if you want to do hot deployment, you can put in the deploy folder your bundle. So your jar you can put in the hot deploy folder, and it will be deployed immediately. This you can use for testing purpose. When you are doing the development testing, you can do the hot deployment. If you are doing the deployment in UAT or production, then you will be doing the feature deployment. So feature deployment is like in hot deployment, what happens? Whatever jar is required, you copy them in deploy folder, and they will be available. In feature deployment, what happens? You don't copy anything in the hot deployment folder. Rather, you prepare a list of application bundles, configurations, dependencies in a nice XML file that is called feature file. That is equivalent to your deployment descriptor. So in that deployment descriptor, we'll write what are the application jars, what are the other third-party jars, what are the other third-party modules, what are the properties file you need, what is the version of all those things. So you will define them nicely, and then you will deploy that. So your application will be deployed as a module, not as an individual code base. Okay. So we'll see how to do feature deployment in one of the sessions. But for testing purpose, quick testing we can do usually with the hot deployment. Okay.
Yeah.
So now, what basically we need to do is, first of all, we need to know what kind of application you can develop in Fuse. So you can, so basically, Fuse is using Apache Camel for doing the integration, for writing the integration logic. So Camel is the routing and mediation engine inside Fuse, and it is being used by Fuse for writing any integration logic. So Camel provides you many options in which you can write your integration logic. So you can use Spring. So the language in which you can write integration logic in Camel is called DSL, domain specific language. So domain specific language is like the type of language where which you can use to write the integration logic. So integration is like what you have to write some business logic to connect to systems and do some processing of the data and then send from one system to another system. So that code or that logic you can write in multiple ways. So the way you write is called DSL, domain specific language. So Camel has support for multiple DSLs. One first is, which is most common, is Spring. So you can write your Spring code which will do the integration in Camel. If you are familiar with Java, more with Java, you can also use Java DSL. If you are more familiar with Groovy scripting, then you can use Groovy DSL. If you are using OSGI, Camel can be used on both the OSGI and non-OSGI server. You can also use Camel on Tomcat, and you can also use Camel on Fuse. So Fuse is a OSGI server. Now Camel is Tomcat is a non-OSGI server. So if you are using OSGI server, then you can also use a very specified version of XML, which is called Blueprint. So you can also write your routes in Blueprint. So depending on your project need and the requirement and your familiarity level, you can choose any one of the domain specific language and write the DSL. Based on the DSL, there will be some slight change in the way you write the routes, because Spring will be a little different to Blueprint, and Blueprint will be little, different with the Java DSL. Java DSL will be different with the Groovy DSL. So there will be some variation. But what are the components you can use? What are the patterns you can use? What are the data formats you can use? Or what are the configuration you can do? All of them will be common in all the DSLs. It's not that if I'm using Java DSL, I can only use 20 components, but in Spring DSL, I can use 40 components. It is nothing like that. You can use all the components, all the patterns, all the configurations, data formats in any of the domain-specific language. So for testing for our example purpose, most of the DSL routes will be writing in Spring DSL, and but we'll also see some example in Blueprint and also some example in the Java DSL. So that at least you are familiar with 3 domain-specific languages. Okay.
What is the thing?
So now, before we just start writing any route and all, and start seeing some demo on the Camel side, we need to understand what is the structure of the application in Fuse. So what you can do, you can go to Developer Studio and you can try to create a new project. So you can say new, and go to other, and then you can create any project using any of the project type. So you can use, based on the plugins that you have, you can use Fuse tooling, and you can create a Fuse project, or you can use Maven, and you can create Maven project. So if you say Maven project, so what is the advantage of using this is, here using the Maven, you can create different type of project. Different type of project means sometimes you will create a Java DSL project, sometimes you want to create Spring DSL project, sometimes you want to create a Blueprint project, or you want to create a project for, let's say, for getting a war file or something like that. So many type of projects can be there, and what is the difference between these projects is the structure of folders and imports that you will be doing, form dependencies changes. So instead of remembering all of things together, suppose that today you want to create a Spring project. So there will be some folders like src main Java, then you will have src main resources, and then you have some meta in a folder. In case of Blueprint, the folder will be Blueprint INF instead of OSJ INF instead of meta INF. Then you don't want to remember all those things. So what we can do is there are already built-in templates. Those are called artifacts, archetype. Okay, those are built-in templates, and they contain some sample folder structure and some sample files to start working. So you don't need to remember the structure of the folder for each different type of project. You can use this template, which is called the archive, and then use it. So you can, based on your requirement, you can choose what kind of archetype you need. So I want to create some Spring project. I'll say all.apache. Then I can choose what kind of project I need. So I all.apache.camel. I want to create a camel project. So I will say all.apache.camel. Here I can get many different types of camel project. So if I want to, for example, if I want to create a Blueprint project, then I can choose this one, or camel archetype blueprint. Then it will give me a Blueprint project. So here you can see the description also. Creates a sample new camel project with Blueprint support, ready to be deployed in OSGI. If I want to create a Groovy DSL project, then it will create a Groovy DSL project. If I want to create a Java DSL project, it will create a Java DSL project. So based on the different archetype, you can choose different project structure, and then you can use any one of the project. The advantage is you don't have to remember the folder location. It will give you a small template. So if I want to move Spring, then I will choose Spring project, Spring DSL support. If I want to move Spring DM, then I will choose Spring project, which can be deployed in OSGI. So for normal work, you will choose, if you are going to write in Spring, then you choose camel archive Spring DM that can be deployed in Spring DSL. And if you want to use Groovy, you will choose a Groovy one. If you want to use Java, you will choose Java. If you want Blueprint, you will choose Blueprint. Based on this, then here you can give the detail of the project. So we will be creating a Maven project. So if you have worked with Maven, you will probably know that how the Maven is structured. So you need to have a group name, then you need to have an artifact name, then you need to provide a version, and then you need to provide some description. So group name is like how you want your project to be structured. So normally in one company, normally the people will use the company name as the group name. Suppose that if I am working with XYZ corporation, so I will say com.xyz. Some department name. So I'm working in the IT department. Maybe I'm working with the finance IT department. So I'll say Fin IT. So that is my group name. Inside so all the people will be using the same group name for the financial IT projects. Inside that artifact, you can give a name of your project. So inside the financial IT, Fin IT, I am providing a project for banking. So I'll say banking, bank API. You can give some version like 1.0.0, So depending on the requirement, you can feed all those data. So here you can give those data. So I'll say com dot xyz dot pin ID. Artifact is bank hyphen API. I'll explain what is the meaning of this. Here you can choose any version. So I'll say version is 1.0.0 snapshot. Okay. So here the name of package will be. Here you can all the base package will start with this group ID and artifact ID. If you want to make any change, you can do the change. But normally we keep it. So then you say finish. Then this project will be created. So once this project is created, it will be visible here in the project explorer, and then you can use that project to do the. You can now make change in the project and start using it. So once this project gets created, we'll just see this structure of it. It is taking some time. Now the project has been created. You can see Bank API project. So here it is a Spring DM project, which means it is a Spring DSL project which can be deployed in OSGI. Fuse server. You see the structure of this project. You see there is a source folder, there is a readme file, and there is a POM file. So POM file is used for building the project. So in this POM file, the project related information is there. When you build this project, it will be creating a jar file which we can use for deployment. Okay. So here you will see src main Java. Here you can com.xyz.finid or bank API. Here you can write your in this package you can provide all your Java code if you have any. There will be a resources folder. Inside the resources meta-inf, there will be a camel context.xml file. So this is the file where you can write the routing information. Okay. So in this, if you open this file, there will be some sample route already present, and this sample route you can remove and write your own actual route. Okay. So this is the advantage of using archetype. You don't have to remember anything. You don't have to create the files from scratch. You can use a template and then get the project. Okay. Any question on the project creation side?
Yeah, fine. See you.
So if you here, if you see, since we are using GUI, you can see there is all the components which are provided with Camel are available here. So this is the drag and drop palette from where you can, if you want any component, you can choose, and based on the requirement, you can drop them. And this is the design. If you go to the source, you will see the source in the Spring. Okay, since we are using the Spring DSL, we are having the source. Okay. So any change you make in the design and save it, it will be reflected in the source. Okay.
Yeah.
And if you click on any component, here you can see the detail of the component in the back. Here, suppose that this is a timer. A timer is a component which has a. We'll see, go through this now, some of the useful component one by one. So timer is one component which you can use for running any task at any given interval. So here by default it runs in every 5 seconds, and then you can also see advanced options on the timer. So if you want to configure anything extra, then you can see. These are the how from where you will know this. You need to go through the documentation of timer to understand what are the properties. So for that there is a documentation tag. So this loads the documentation of timer, and we can learn more about it. So what is the use of timer? What is the various options that we have? So all those things we can see from here. Okay.
Which component this one?
This is a timer component.
Okay.
So if you don't want to see the documentation here, because this may not be getting updated all the time, you can also go to Google and say whatever, you can just search for this camel. You can just say camel component. So if you say camel components, you will find the first page itself, camel components, Apache camel components. Here you will have a more detailed list of all the components. Like I think 200 plus components are here. So here you can see the big list of components, and based on your requirement, you can choose any component. Suppose that I want to integrate with a file, so I'll click on this file component, and then I can get a more detailed page of file. What is the file component? What is the format? What are the various options available on file component? Some examples, some small examples. What are the various properties we can use on the file component? In what version of Camel, what feature is available? All those things we can find from here. So you were saying that you want to use the Red Hat Fuse 6.3, right? So
Yes.
in 6.2 also file component is there. 6.3 also file component will be there. So what is the difference? There may not be any difference because they may not have upgraded the file component in 6.3, but there could be some extra features that can come with the extra properties that can come with the next version of Camel. So Fuse is using Camel. If Camel is making any change in file component version with the new version of Camel, then you can find and see it here. Okay.
It's not major difference, just UI, I think.
Yeah. No. See, let me tell you another thing. So Fuse is using internally Camel, right?
Yeah, correct.
For the integration, it is using Camel. So Camel has multiple versions. So currently, I think what is the stable version is 2.18.0. I think that is the stable version. Suppose that is used in Fuse 6.2. Okay. In Fuse 6.2, suppose that in Fuse 6.2 we are using Camel version 18. Let's say you go to Fuse 6.3. So there could be a change in Camel version. So they can say we will be using Camel 2.20, let's say.
Okay.
So in Camel 2.18 for file component, they may be giving 100 properties. Okay? But in 2.20 file component, they may be giving 110 properties. Because in 2.10 version, we might have found that okay, something is not working properly, or something is not performance is not good. So they may improve something in the next version of the Camel version. Okay. So that will be the only difference. Otherwise, apart from UI and all, there will not be much difference component wise. You got the point, right?
Got it.
Yeah. So they may be providing some extra functions, or they may have fixed some issues that they will be releasing in the new version of Fuse, which will be also containing new version of Camel. So if you want to compare between 6.2 and 6.3, you can see what is the Camel version they are using. And if the Camel version is same, then functionality wise there will not be any difference. But if there may be some difference in the UI and how you drag and drop and create the routes and all those things, that is a different thing. That is a tool feature, not the Camel feature.
One more question is
Yes.
we are using Spring, right? Actually, which one is better, Blueprint or a Spring PSL?
So it is Spring is common. People are using it from a very long time, and Blueprint has come after the OSGI server. Okay. What is the difference is Blueprint. If you write a route in Blueprint, you can only run in an OSGI server like Fuse.
Okay.
But if you write a route in Spring, you can run in Blueprint or OSGI also and non-OSGI also, like Tomcat.
Yeah.
So suppose that today you are using Fuse 6.3 and you are writing a route in Blueprint, and 1 year after the development, your company says, no, Fuse is not good, we will go back to the Tomcat. Then the routes that you have written in Fuse will not work because it is written in Blueprint.
Okay.
You have to rewrite everything again in Spring. But Spring is supported in both the Fuse and Tomcat. So it has backward compatibility with the non-OSGI servers also. But Blueprints are only compatible with OSGI servers. That is one difference. But there are advantage of using OSGI in, but there are advantage of using Blueprint in OSGI servers. What is the advantages? First, it is written with OSGI in mind, right? It is more optimized for OSGI server. It may perform little better. So the routes written in Blueprint can perform better compared to routes written in Spring in OSGI server like Fuse. Maybe you'll get some little performance improvement.
Thanks.
Second thing is the OSGI provides a lot of extra services for administration and configuration. So if you write a route in Blueprint, they have direct connection with OSGI where you can use the OSGI services in a very simple way. So you can suppose that OSGI provides a 5-word service. So you can use that service from OSGI and integrate very quickly with the Blueprint. But same thing if you have to do with the Spring, you may have to write some extra configuration.
Yeah, thanks.
At the end of the day, you can do both in Spring and Blueprint the same thing. But in Blueprint, you may have to write 10 lines. But in Spring, you may have to write 50 lines of it. Or same thing. Okay. But not for all things. Few things which you want to extract from OSGI, then it is more optimized. But if you want to do normal operation integration, then both are same. Okay.
Yeah.
So now we have a small route here which came. What it is doing is it is reading from a timer and calling some bean, and then this message is logged. So where is the code for this? The code is here inside this RC main Java. So there is a hello Java interface. Here method, and there is the implementation for this method. So yeah, you are just converting into the data for some date. So what we need to do? We need to see how this project is structured. We know it, how it is structured, how the form is used for dependency management. So if you open this project, you will also see a form.xml file. This is the file which is used for defining the dependency of your project. So if you see in the form file, first of all, you will find this 4 or 5 lines, like what is the group ID, what is the artifact ID, what is the version, what is the packaging. Okay, and then you see some dependency. So what are the dependency you need for your project? So here I'm using some dependencies like camel. I'm using something like camel code, camel spring, and for testing purpose I need some camel test spring, and I need some log for J for logging purpose. So in the project you will define all the dependencies which you need for your project. In the form file, you will define everything. Okay. So here, if you are using any third-party libraries, anything from the external vendors, from your team member, anything, all the dependencies you will be providing here in this form file. Okay. And then in this form file, there will be some plugins to do the build. So first of all, you need to compile your code. So there will be a compiler plugin. Then you need to bundle your resources. So there will be resource plugin. And then there will be a plugin to create a manifest file. So this manifest file will be basically used to define your dependencies and services. This will be which will be used by Fuse to resolve the dependencies. So if I have to build this project, what I need to do? I need to go to project, right click, and if you're using ID, then the Maven will be integrated with this. So you can say run as Maven install. So once you say run as Maven install, it will try to build the project. So you can see that in the console. So here you can see what is happening. So before that, what I do, I will start my Fuse service.
Run through that folder, freeze folder.
Sorry?
Run through freeze folder, inside freeze folder.
Okay. So you see this Maven runs through Fuse?
Not Maven, freeze only.
No, I didn't get it. Can you please repeat?
Yeah, you can run it through from here, bin, using bin.
Yeah. Okay. So bin, if you're using bin, then you're running in a console mode. If somebody close that window, then your Fuse will stop. I'm running as a Windows service.
Okay.
I'll share one document through which you can install Fuse as a service. So I'll share a document so that you can do it.
Okay.
Okay. So now my build is done, and in the target folder you will find the package. So just refresh it, and in the target folder you can find a package. So what we'll do, we'll go here to this folder location. My project is in this location. So after building the project, you can go to that location and you will find a target folder. Inside the target folder, you will find a jar file. So if you open this jar, so you will see COM, XYZ, definite package. Here you will have the class, and in the meta-inf, you will have the Spring, the route, and then in the meta-inf, you will have the manifest.mf file. If you open this manifest.mf file, here you will see some information like who built the project and all those things. Also, you will find the name of the bundle name which you have provided in the Spring, and you will also have the bundle version, and then you will have the one export package. It's like what are the services you are providing for others. So in any OSGI bundle, you will find two important information. One is the export package. This is the export package, and then there will be another import package. So export package is the service that you are giving to others. So in our code, we have a package, right? In the bank API, we are having some classes. If I want to give that as an API to other people, I will be putting them in the export package in the Maven. If I want to use any other property, any other package, then I will be calling as an import package. Okay. So import package are the dependencies that you have in your project, and import package is also coming from the import statement of your Java code. Okay. If you have any Java code and it contains any import statement, they all will be your dependencies, right? So if you write a Java code, you will have some import statement in the Java code, right? In a Java class.
Yeah, I'm listening.
Yeah. So if it is a Java class, then you will have import statement. Import statement means you need all those packages for running this particular class. Suppose that you have 10 import statement. It means that 10 packages are hello?
Yeah, I'm listening.
Okay, sorry. So it means that if you have 10 import statement, it means that you need 10 classes from some packages. So all those packages in the import statement will be created as a manifest entry inside this file, and it will be called import hyphen package. So it will contain a list of all the packages that you are going to use. So right now we are not doing import because we don't have any Java code which is using any third party. So then we can then it will not be created. If you have any Java code, it will be created automatically. Now what we need to do, I have started my Fuse service. and then I need to do some deployment. So Fuse also provides a console through which you can connect to the Fuse server. So Fuse runs on a SSH port. So it's a secure server host port. You can connect to it using any tool like Putty. So you have to give the name of the server and the port where it is running. By default, it uses 8101 port. That is the default port for the SSH. But you can change it as per your requirement. So I am using 62616. For your case, it could be 8101 since you have not changed it. Then here it will ask you for a username. So username and passwords are defined in a file called system users.property in etc folder. So I am having an admin user and the password is also same. So now I am able to log in here. So if you go to the Fuse folder, in the etc folder, you will have a user.property file. Users.property file. Here you have to define some users which will be able to access Fuse. So you can define different users and their different roles, and based on that, you will be able to access. So here, this is the Fuse console or graph console. Okay. So this you can access remotely. You don't need to log into the server where Fuse is running. You can connect to it remotely. So here, there are some commands which we will be seeing in some session. Suppose that I want to see the list of all the applications which are running. So I will run a command like osgi list. So if I run this command, I can see all the services, all the applications which are running. So I can stop any application for admin purpose. So I want to remove some application. So I'll say osgi uninstall 293. So 293 is this application. I want to remove this application. So I will say osgi uninstall 293. So now if I run the old command osgi list, I will not be seeing that 293 application. Now the last application is 292. It's gone. I want to uninstall this one also, osgi uninstall 292. And if I run the list again, this is gone. So like that you can, if any application is there, you can remove it. If any application is not there, you can install it. For installing, you need to copy the application and put into the deploy folder. If you put in the deploy folder, then the application will be hot deployed. Okay, so I am doing hot deployment now. I will just copy this into the deploy folder. And if I go here and run the command osgi list, I should be able to see this new application which is running now. Okay. So we just created one sample application from the ID, and now it is getting created here. It is installed here. Okay. So this application contains some camel code and some Java code. So we'll quickly see what this code is doing. Okay. This camel code is here in the camels. So here in the code, what is happening is it is Spring code. So all the route will be written within these two beans. So there is a beans definition. So all your camel code will come here. So the routes in camel is written inside a node called camel context. Okay. So we'll go through the hierarchy. And inside a camel context, you can have any number of routes. Inside one route, you need to have an input which is indicated by from and doing some processing, and then you should also have. You can also have output. Okay. And if you are using any Java code, that Java code you can indicate using a bean. So this is like Spring based configuration. So I'll explain this. So what is happening here is we are reading from a timer. This timer is running every 5 seconds, and then I am calling a Java code to do some operation. So this operation will be calling, and then it will be doing some log. So where this log will be going is, if you go to Refuse home, you will have a data folder. Inside data folder, you will have log folder. Inside log, there will be a fuse.log. If you open this log, go to the end of this file, you will see that this timer is this message contains hi from camel. So this is the processing that is done by this route. So it is logging every 5 seconds some message coming from the timer. Okay.
Yeah. In console, I will test.
Sorry?
In console, Fuse console. Management.
Fuse console, what? Fuse console, you want to see the output on the fuse console?
Yeah.
So you can write a sysout statement, then it will be doing that.
No,
But normally on the console,
not that console. I'm saying that web browser console.
no, so okay. So I'll explain how the route is working. Then you will be able to understand how you want, where you want to test. Okay.
Okay.
Just give me a minute. So let me just stop this route, otherwise it is just sending logging lot of message. So SGI stop. If you want to stop, you can say SGI stop. It will stop that number. So I'm saying this number because this number is the identifier of this application. Okay. So if I go here, then it will be stopped now. It is not active now. So how the route is working, I will explain you first. So in Camel, all your routes should be written within the Camel context. Okay. So the hierarchy wise, you have a Camel context. If you see in this, you have a Camel context. So Camel context. Camel context is like a wrapper or parent for all the routes in Camel. Okay. You will have only one Camel context in one application. Okay. So inside a Camel context, you can have a route. A route is like a small integration logic. Inside one Camel context, you can have multiple routes. So I am having route here, and I am having another route here. So I am having two routes. So inside the route is like integration logic. So you will have a parent, that is the Camel context. Inside that parent, you can have multiple childs. Each child is a route. And inside the route or child, you will have some input and processing and output. So you need to have an input. See, integration will work when you get some data, right? Then only integration will work. No?
Yes, correct.
So for getting the data, you need to have input from URI equals to input. You have to give some path. So basically, this is your input. From here, you will get the data. Okay. And then after you get the data, you will do some processing. So you will do some processing. Processing 1, processing 2, and like that you will do some more processing. So you will go till here, processing 10. And once you do the processing, then what you want to do? You want to give this data. Processing means you are changing something in the data. You are doing adding, removing, you are changing the format of the data, you are changing the content of the data, you are making from one object to another object, like that you are doing. And after that, once all these things are done, you want to give this data to someone else, right? For next processing. Then you will have a 2 URI equals to a path where you want to send. This is the output. Okay. So in any Camel route, you will find all these steps. So you will see one input, one or more, 0 or more processing, and 0 or more output. Okay. So processing is optional. You may not want to do any processing, and output is also optional. You don't want to give it to someone, but there will be at least one input so that you can start some integration. So are you clear with the structure of the route?
Yes.
So you will have one Camel context. Inside one Camel context, you can have one or more routes. Inside one route, you will have an input. You can have one or more 0 or more processing steps, and you can have 0 or more output. Okay. Same story will repeat inside this route also. This is one route. Similar thing will be there inside another route also. So here you may not have any output. That is okay. You may have only, instead of n steps, you can have only one step. That is also okay. So depending on the requirement, we'll have one or more processing step. We have one or more output. But in all cases, there will be one input. Without input, you can restart. So from is mandatory. Other things are optional. So if you go back to our example, what we are doing, we have one camel context. Inside one camel context, we have one route. Inside the route, there is a from, which is the input. So this is the input. What is the input? Type of input? The type of source of input is one timer, which is running every 5 seconds. So this timer will run every 5 seconds, and then we'll do some processing. So I'm doing one processing here, I'm doing another processing here, and after that I'm not doing it. After again 5 seconds, this will execute, same thing it will execute. It will keep on executing same thing every 5 seconds. Okay?
Yeah.
Okay. So this is one thing. But how the processing works in camel? What is the data which is exchanged between multiple steps? So when you have a camel context, you will have a route. Inside the route, you will have an input. The input is called exchange in camel. Okay? It is called exchange. So this exchange is something that you are getting from the input. Or the exchange is something that you are giving to a processing and getting from the processing. The exchange is something that is giving to output. Okay? So exchange is basically, so in camel what we are doing, from is the input source, right? So this input is the, what we are doing, we are connecting to some component and getting the data. So component is like the proxy for the real world entity. Like suppose that you have to read from a file, then we will connect to a file component. If you have to read from a web service, then you will connect to a web service component. So what Camel has done is, Camel has defined a lot of components for connecting to any real world interface. So what are the real world interface? Files, real world web services, JMS queue, database, timers, any AWS component, any social media component. So all these things are external world entities, real world data interfaces. So for connecting to any database, Camel has provided any data, and Camel has provided some database components. Connecting to a web service, Camel has provided some component. So like that, Camel has provided different components for different purposes. If you want to read from a file, Camel has a file component. If you want to read from a FTP, Camel has a FTP component. So what these components will do, on behalf of your integration, they will go and get the data from those input. Okay. So suppose that you get a comment that you need to connect to a file folder location and read some files, and then after reading the file, you have to give it to send it to a JMS queue. So you don't have to write any code to connect to a file component, file interface. Or you don't have to write any code to connect to a message broker component. So already Camel provides you some components that you can use for connecting to these real world entities. So the link I shared with you, right? This link which I showed, Camel components. There are a list of all the components, but we will not need all of them. So in general, we need few components like what are the common components that we use? Most of the common component that we use is endpoints like file, direct. These are the common components that you normally use: files, direct endpoint, JMS endpoint, SEDA, VM, CXF endpoint, JDBC for database, HTTP or Jetty for HTTP, validators, web services, RESTlet component, CXF component, timer component. So these are the common components that you will be using for the your integration world. Similarly, Camel also provides a lot of patterns. So enterprise integration patterns. So these enterprise integration patterns, using these patterns, we can do some activity without writing much code. Suppose that you have a requirement like you will be getting data, you will be getting a big file, and your requirement is to break. Suppose that the file contains 1,000 lines, entries, 1,000 entries. Your requirement is that you have to get at a time you have to get only 100 entries from the file. So, and then you get 100 entry from the file and give it to one more process that will be processing it. So, if you have to write that kind of logic, what you will be doing, you will be writing a Java code. The Java code will load the file, and then you will write some splitting mechanism, and then splitting will give you 100 lines at a time, and in a loop, it will go in a loop. And then first of all, you'll find how many lines are there in the loop file. Then using that, you learn as you can write a loop that will go through all the files, and then it will give you the 100 files at a time, 100 data of the file at a time. But in Camel, in order to do that, you don't have to write any code. You can use a split pattern. So Camel provides a splitter pattern. Using this split pattern, we can split any data from the exchange, from the message. This is split, you can pass some parameters and split according to your requirement. So this is the pattern you can use. Similarly, you are getting some 20-30 record data, and you want to combine them together and send one response. Then you don't have to write any logic to do that. Camel provides an aggregate pattern. This is the aggregate pattern. You can combine some records as per your requirement and send them together. Similarly, Camel also provides filters, content-based routers. If you want to send data to multiple people, you don't have to send them one by one. You can use some patterns to send all of the data together in one go. You can use some pattern for that. You can, if you want to get some data from one source and get another data from different source and combine them together, you can also do that. So Camel provides a lot of patterns which we can use. So some of the commonly used patterns are like this. We'll be going through some examples to understand what is the content-based router, dynamic router, filters, split and aggregators, enrichment, so resequencer, normalizer. So we'll go through all these patterns to understand how they work, and without writing much code, how can we do a lot of work? Okay. So here, what is happening? I am getting input from one component, and then I am doing some operation one, then I am doing another operation, and then after. So this route will execute every 5 seconds, and the same thing will happen. So you will see a log entry in the file that something is getting logged in the message. Okay.
Yeah.
So this is your hot deployment and creating a sample project. Now, if you have to enhance this project, then you can write more routes inside this Camel context, and you can also write some Java code that you can refer. So Camel has very good support for bean integration or Pojo integration. You can do a lot of work in Pojo, and you can call those Pojo as a bean in your Camel routes. So here what we are doing is we are defining some Java code which will be doing some operation and declaring them as a bean here. By default, these beans are singleton, and then you can use them inside your routes by calling the some of the bean integration methods. So we'll see some of the bean integration methods in the coming classes, how it can be used, and what are the different ways to do the bean integration, and how can we do more and more processing in the beans. Okay. Going back to our last discussion of what is getting exchange between route and all. So here my one route is here, which is getting data from. So I have one route which has input, and it has some processing steps, and then it is an output. There is another route where some input is there, only one processing is there, but no output. So how the message is getting transformed from one part to another part in the route? So routes are executed in a sequential manner. So first step, then second step, then third step, then fourth step, and like that it will execute. So in each step, you will get one input, and then there will be some processing, and then you get an output, and then it will be going into the next. So input from output of one step is the input of next step. Okay. So what is the data model that is actually exchanged between routes? So that is called exchange. Camel exchange is a very useful topic. Once you get time, you can do also some reading about it. But I'll explain you in short what is the structure of the exchange and how it works. So exchange is the data model that is used inside a route. So exchange is the top level entity. Under that we have properties. Then we have body, and then we have attachment. Okay. So in any exchange, there will be some properties. There will be a message body, and there will be a attachment. Okay. Attachments are optional. Properties, there will be some default properties, and that should be body. The body is of two types. One is in. Okay. In. So instead of body, let's say message. So body is of two types, in and out. Correct?
Yes.
So in means incoming data, out means outgoing data. So in means it will also have some headers, and then it will have a body, and then it can have some attachment. Similarly, out can also headers. It can also have some body, and it can also have some attachment. So this is the structure of exchange. Exchange will have some properties. Properties are like message headers. These are like message headers. Headers at exchange level. Okay, those are called properties. So message headers at exchange level are called properties. Message headers are also there in the message body, but those are called the message headers, and they are local to the in or out. Okay. Properties are available to both in and out, but in header is only available inside in, out header is only available inside out. Okay. So body is the actual input. Here is the actual message. This is the actual message. Okay. Attachment is any attachment you want to attach a file or you want to attach an image, that kind of thing. So if you have any, suppose that this is the exchange. So I am getting an input here, so I will get it means I am getting an exchange. In this exchange, there will be some properties like name, ID of the exchange, time of the exchange. Then I will have a header. That header are the properties. Then I will have a message. So if I am getting in for the first time input here, then I will have only in message, right? If you are getting input for the first time, you will have only in message. Correct?
Yeah.
Out message will be empty because you are just getting now for the first time. Now I get the message here, input, and then I need to pass that to next step. So if you have no output, what I said, output of one is input for next. Correct?
Correct.
So if you don't have any out, then what is the input for next? So if you don't have any out, the in is copied to out. Okay?
Hmm.
So here what will happen? There is a in. So here you will get the in, but there is no out. But for processing you need in and out. So what will happen? In will be copied into out. Correct?
Yeah.
Then here it will get in, new in, right? Are you able to follow this?
Yeah. Yes, yeah. I'm following.
Yeah. So in, you got an in, but there is no out, so in is copied as a out also. So now that out becomes in here. Now in this processing you will be changing some exchange. You will be doing some operation on the exchange, and then you will be doing some operation that can change the exchange. If you are able to change the exchange, you will have an out, right? Or if you are not doing any change in the exchange, then again in will be copied as the out. So depending on the type of operation, you can have out also. If you are having out, then you will have out message. If you don't have out, then you will have only in message. Correct? That in will become, if you have out message, then this out will become in here. And this, if you don't have out, then this in will remain the same. So like that, it will go, keep on going and checking depending on the result of the operation. You will have always in message, and you can have out message optionally. If you have out message, that will become in for the next operation. If you don't have out message, in will become the out for next operation. Okay. It means that sometime when you do operation, you send in and you get out. So that is called this pattern. When you send the data and get some data back, it is called in out message exchange pattern, MEP. Okay.
Yeah.
MEP is message exchange pattern. If I give you 100 rupees, you also give me 100 rupees, it is called in-out MEP. If you give me 100 rupees but I don't give you back, it is called in only. Okay?
Yeah.
So here only in is there, no out, then it is called in only. In only MEP. Okay?
Yeah.
But as I said, always we should have in and out, because in of next step 2 is out of step 1. So if you have in only, then it will contain both in and in the in out. Okay.
Yes.
So where you will find the difference in this? Suppose that you are sending a data to a JMS. So there are some components, there are some real-time things where you call and get some response, like web services. So if you call a web service, you will get a response back, right?
Yes. Yes.
So you will call and web service with in, and you will get an out from the web service.
Good.
But if you call a JMS queue with in, you will not get anything back from the queue.
Yes.
Yeah, so that is in only. So in the real world, we have some process which are one way, like they are asynchronous. So those, in that case, we have in only message exchange pattern. Okay.
Yes.
In the real world, we have some entities which are synchronous. So we'll have in out pattern. Okay. So based on the entity where we are interacting, we'll have either in out or we have in only. Correct?
Yes. Yes.
So that is the important thing we should be knowing and clearing this at the beginning of the session itself, because our entire processing will depend on this understanding.
Yeah.
Okay.
Yes.
So now let's go back to the route again to understand what is happening. So I am reading from a timer. If you read from a timer, it does not give you any input.
Yes.
So here in also is empty. This is a special case, because when you run a timer, what it will give you? Nothing. It only runs at a given time, that's all, right?
Yes.
There is no input that is coming from a timer. So if there is no input coming from a timer, your in is empty, right? But we must always have an in, because if your in is empty, it will throw null pointer exception in the next. Because if you are trying to copy in into out, and it will say in is null, out is also null, so there is a null pointer exception. Okay. So whenever we use a timer, we should always use a pattern to set the body in that timer. So for setting any body in the message, in body, we have to use set body pattern. Okay. So set body is a pattern. Using this, you can set data into input body. So we have this structure, right? In body, I want to set body.
Yeah.
My timer is started, so it is in for me. Now it is null. The body is null. So I have to set a body, because if I pass this to the next statement, it will throw exception. Because if I don't have this statement, then the next null will go to this statement and it will throw exception. Okay?
Yeah.
So we need to have a statement which will set the body, and then based on this body, this a message will be constructed, and then after the operation, this will go to the next statement. So for setting this body, what we are doing, we are calling bean. This bean is printing the response on setting the recording on my behalf. So this Java class will be called and it will set some body. Now the Java class is setting the in, and since there is no out method, so the in will be copied into the out, and that out will become in for this next statement. Okay?
Yeah.
So this log is a synchronous, asynchronous process. If you log, it will not return you anything, so there is no output from this statement. So the in will be copied to the next statement. So, but right now we have no more statement, so the route will stop here. So route will start, get the start the timer. It will set the in body, then that in body will be copied to the out body, and that will be passed to the log statement. After that, route will stop. Okay. Any question on this route and how the patterns work, how the data comes from one route to another route?
Yeah. As for it's clear, no issue.
Okay. So now we have seen how to create a bundle of the application jar, how to deploy it in the Fuse in the hot deployment mode. Also, we have seen how to connect to the Fuse in a console mode. So you can use this SSH port, and then based on the SSH port, you can use any tool like Putty to connect to the server. Okay. Also, Fuse provides a nice GUI. So if you Fuse uses 8181 as a default HTTP port. So if I have changed it to 8161. So, but if you have not changed the port, it will be 8181. So I have changed it to 8161. So it is coming on a different port. If you open this port, you will find it will ask you for username and password. That is the console application console of JBoss Fuse. Okay. This is the management console of JBoss Fuse. So here, since you are running multiple things, here we can manage all of them. So if you want to know what is the number of threads in the application and how many threads are running, how many blocking, how many waiting, how many suspended, you can go to those threads tab and see all the information. If you want to connect to a Putty terminal, so here what I did, I exclusively connected to a terminal, right?
Yeah.
But if you want to connect to the remote UI, then you can do through terminal. Here you can run all the commands, and once you run the command, you can see the output and all. So here this route may stop. If you want, we can start from here also. So we can just say plus GI start 294. If you run the list, you can see it is started. Okay. And here we have OSGI, so where you can see the list of all the applications which are deployed. So this is like a nice UI, and this is the terminal for it. Okay. Then you can, if you want to see the logs. So right now we are seeing some logs, right, which are getting logged by this application. So here you can see all the logs are getting logged now. So high from camel at blah 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 12:35. So every 5 seconds it will run and one log will be put here. Okay, we can see that. And you can also, if you have worked on J console, you can also find that there is a J console like UI here where you can see the ambience exposed by the applications. You can also see the overall health of the broker, and you can also have a dashboard where you can see what is the CPU load, memory load, and all those things of the server. Okay. And since we are running camel routes, you will also find this camel tab where you can go and see what are the routes running, and this route, how many endpoints are there, and how many you can see the details like for this route, how many time it has run, statistics you can see. You can stop the route from here also, and you can also see what is the source of this route. This is the route we are running late. So so all these things are deployed in Fuse, and then you can see from here. You can manage all of them from here. If you want to change something, you can write it here, and then you can update. Then it will be updated in the camel. So if you want to do some live debugging, live troubleshooting, you can also do from here. So if you want to debug the route, you can just click on the route, and then you can go to debug, and you can start debugging of the camel route in a live environment. So all these things are features that are supported by Fuse, and you will not find these features in the normal camel standard application. Okay?
Yeah.
Fine. So any question, any doubt?
I have found nothing. I want to know about this one. Bin, you are changing something, right? Nav etc folder.
Sorry? Bin etc folder?
Yeah, starting that initially we said something that in etc folder, Maven you were setting something. Just explain about that one.
Yeah. So in the bin you will have this fuse.batch file that you will be running, right, for running your.
No, etc folder.
Okay. In the etc folder. Okay. So what I wanted to explain was Fuse. Yeah. So Fuse has, let's say, for example, 500 features. Okay. So this is the total capability of Fuse. 500 features are there. But when you start Fuse, all of them will not start at the same time. Okay. So let's say only 150 will start. 150 will start. Why it is required is because if you want to start all the features, it will take a lot of time, correct?
Yes.
Because you need to load all the applications, and then you need to load all the configurations, and you have to manage all the dependencies, everything. So it will take a lot of time, first point. Second point is, you can build a very rich application, but not everybody will be using all the features.
Yeah.
Yeah? So there is no point in starting all the features which 90% of the time people will not use. So what they do is they identified that for running a basic thing, I need only 150 features, and other features can be started as needed, as required, on demand. So out of 500, only 150 will be started, and remaining can be started on demand by the user. So what they do is, in the etc folder, there is a file called features. I will provide that list anyway with you. Features.configuration, this file. Apache features.configuration. If you open this file, here you will find something called features boot. The comma separated list of features to install at startup. So when you run Fuse anytime, these are the features which will be started by default. So these are the list of things that will be started by default. So there is a minimum thing that will be running all the time. If you want to, you can go back and ask Fuse to install a new feature. Okay, by by making change in this property file or by doing it on the command line. We'll see one class will be there to understand the features and understand the commands in OSGI. That will do one session, then you will understand more. But to tell you here, you can either change this file and add a new feature which you want always to run. Suppose that I am running deploying a JDBC application. So I want a Spring JDBC always to be available. I don't want it to manually start it. So you can go and make this change in the file and restart the service. It will be always, so whenever Fuse runs, this Spring JDBC will be always available.
Okay.
Okay, so this is one approach. Or you can manually do it from the console, the Fuse console.
Okay.
Second thing is, in the etc folder, you will also find, not etc folder, in the system folder, you will find all the offline repository.
Okay.
So this repository is required because when you deploy your application, you don't deploy any dependency jar with it. You just deploy your application and you just tell what is the dependency in the manifest.mf file of the Maven bundle, right?
Yeah.
So if I just say that I need ABC, somebody has to provide that ABC, right? So that is provided from this system folder. So that is the offline repository. And if you say that I need a Oracle jar, or I need a common land jar, or I need a custom codec jar, then they will be provided from this system library. Okay.
Yeah.
So what happens? Sometimes some of the jar that you want is not available with Fuse. Let's say you are using 6.3 version of Fuse, and it contains 10,000 jars. Okay. As per they will be packaging it one date, right? At the time of the packaging, whatever jar is available, suppose that total jar is available as 10,000, so they will package everything and give it to you. Okay.
Yeah.
And 6 months after that date, you find that there is a very nice API that provides a very good string manipulation functions, and it is provided by some provider. Since it is released after the Fuse release, Fuse will not have that jar, right?
Yeah.
So then, if you want to use that jar, how do we use it? We cannot get that jar from this system folder. So what you have to do is, inside the etc folder, there is another file called ops all.ops.j packs maven url maven.cfg. So this file contains list of all the repositories from where you can download any jar. So this new jar will be available in one of these repositories, definitely, because these are the well-known repositories. They release the jars as they come. So these are Nexus, Maven Nexus repository, Spring repository, Fuse source repository, SVM repository. These are the well-known repository from where any developer will download the jar.
Okay.
Okay. So, but for downloading from this different repository, you need to have internet connection, right?
Yes, correct.
So in production, they may not allow internet because it is not good to connect the system with internet, which is a production system.
Yeah. Then what we have to do?
Then what you will do? In any organization, if they are using plugin-based development or application development, they will be maintaining an internal repository.
Yeah, correct.
Maven Nexus repository they will be maintaining internally. So what you can give the path of that repository here, so that instead of going to internet, you can delete all this, and then you can give the path of that repository here. So instead of going to internet, it will go to your local repository and download from there.
Okay. Yeah.
Okay.
Yeah.
Yeah. So that is the logic we normally use. So what we will do, we'll be doing all these repositories. We'll delete all of them, and then we'll give our own office repository. From there, it will be downloading all the time.
Okay.
Okay.
Yeah.
Okay. Fine. So today I will stop here. And
Okay.
I'll share you the document which will tell you how to run Fuse as a Windows service. You can use the
Okay.
document and try to
Okay.
install Fuse as a service. And tomorrow
Okay.
onwards, we'll start with our course Spring based routes for multiple patterns and components and some of the key features. Okay.
Yeah.
Okay. Thank you very much.
And so one more request. It can take 3 hours, 4 hours class like that tomorrow.
3 hours I can take. 4 hours will be too much.
Yeah, yeah. 3 years. Okay, fine. That should be fine.
Yeah. Saturday 3, Sunday 3, right?
Yes.
Okay. 3 hours is okay. 4 hours will be a little bit.
Okay. Same time, right?
Yeah, yeah.
Okay, sure. Thank
Tomorrow
you.
we'll meet. Okay.
Thank you very much.
Okay.